Hello, today we are going to be going over a physics problem. So our problem today is a 59 kilogram box hangs from a rope. What is the tension of the rope if? So pretty much we have four main parts. First is when the box is at rest. Second, when the box is moving upward at a steady 10 meters per second. Third, when the box has a velocity of 5.1 meters per second and is speeding up 5.1 meters per second squared, and our y-axis is pointing up. Then we have the same exact thing, but this time it's slowing down 5.1 meters per second squared. But first we gotta draw a free body diagram. So here we go. Here's the diagram. Pretty much this just shows that the forces of tension and gravity are equal because we're going to be looking for the net force of them. And to do that, you need to do the tension minus the gravity to get zero. So yeah, that's based off Newton's law right here. And because of this, since net force is going to be equal to zero, you can just set zero equal to force of tension minus the mass times the gravity, because that's how you find the force of the gravity of this box. And one thing to note is that our assumption here today is that the gravity will be 9.81 meters per second squared. The problem didn't specifically state that it's on Earth, but it's easy to assume. And that's the gravity constant, so we kind of need to have it here for the equations. Yeah. So then you can change the equation to be force of tension equals mass times gravity. So then you just pretty much plug in your values, and we get our force of tension equal to 578 newtons. And then for a reasonability check, so we can set up in our net force equation, net force equals force of tension minus force of gravity. So net force will equal 578 minus 578, which equals zero, which ties to our formula. So we're not going to go over that again, but that's how you would reasonable or check for reasonability. Here, the box is moving upward at a steady 5.1 meters per second. We're looking at velocity, and since it's steady, it's not accelerating. So this is the exact same as question one. So our force of tension will still be 578 newtons. Part three, we're only gonna have to change a little bit of things. Pretty much the equation's gonna be the exact same, but since we're speeding up, the force of gravity is gonna have to the force of gravity needs to be more because there's more acceleration on it. So you have to add the acceleration to the gravity constant. It's a little bit extra, but it's not too bad. So then you plug in your values and you would get a force of tension of 903 newtons, which once again you could test with the other formula by plugging in 903 minus the gravity, which in this case would be also 903. And then finally, we have slowing down, which this time uh, it's just going to be the equation is going to be force of tension equals mass times gravity minus the acceleration because it has less. It's slowing down. And this time we get a much lower number, 254 newtons. That's pretty much it. So thank you guys for watching. Goodbye.